Welcome back to the show. We're here with Maciek Lukawski. He is the VP of Strategy and Business Development at Amogy. Amogy builds technology that unlocks ammonia's potential as a clean energy source, and they're accelerating the global journey to net zero and sustaining future generations. Welcome to the show.
Well, thank you. Thank you so much for having me. It's a pleasure to be here with you.
Yeah. And tell us a little bit about Amogy's growth here in Houston.
Sure. So, as a company, we started a bit less than 3 years ago. The company started in Brooklyn, New York, with 4 of our founders. Since then, we have expanded geographically, first to Houston and Norway, then also recently to Singapore. The headquarters of the company is still in Brooklyn, New York, but we're growing very quickly in Houston. And we have also recently made an announcement about opening our first manufacturing facility. We're very proud to have it not only in US, but here in Houston. Many of our team members have roots in Houston, and it's been a fantastic place for growth.
Yeah, and you're making ammonia. I think maybe it's obvious why you got to make stuff here in Houston, but I guess tell us a little bit about why the ammonia market and why that's a significant alternative fuel.
Yeah, so I think it's becoming increasingly clear to various players globally that ammonia will be a significant part of our future as a low carbon fuel. Ammonia is usually seen as a very cost-efficient and effective, highly energy-dense vector for hydrogen. So it's one of available ways for cost-effectively moving hydrogen, large volumes of hydrogen, from one place in the world to another. What benefits ammonia is that for many of low carbon fuels, we don't necessarily yet have the large scale storage and transportation infrastructure. For ammonia, we actually do have it because ammonia has been used for more than a century as a fertilizer. So ammonia is actually the second most commonly produced chemical in the world. It has a global production of about 200 MTA, million metric tons a year. One way to think about this is it's about 40% of the global production of LNG. It's also shipped globally. There are roughly 150 vessels that can move ammonia around the world. About 50 of them are in dedicated ammonia service. So people have been doing this for over a century. That creates opportunities, and the opportunities now are twofold. First, to decarbonize ammonia production, and that can be done through the green path with electrolyzers producing hydrogen and then turning that into ammonia. And the second one is through the blue path, that is using natural gas and then sequestering CO2 underground. Now, where Amogy is positioned in this value chain is we're addressing the one aspect that has not been addressed before. That is, once you have this ammonia at the receiving location, how do you produce power from it? So what we offer is an integrated solution for taking ammonia and producing power out of it. And it's all in a single box. It's a really versatile technology and versatile solution that can be used for decarbonization of mobility applications, especially the big ones that are typically hard to decarbonize, maritime shipping, long distance haul, mining, etc., and for decarbonization of the power generation applications. And we have been addressing this for a while now. We have demonstrated our technology across increasingly large scale, starting with a small drone, through tractor, world's first semi-truck powered by ammonia. And now we're building the world's first vessel. It's a tugboat, so a rather small vessel, but nonetheless, world's first vessel powered by ammonia. So, I think there's a lot of momentum in the market for ammonia. We see this even here. We spoke about Houston before. We see ammonia, blue and green ammonia production capacity in the Gulf Coast region actually being approved, projects moving forward. So, there's a lot of momentum towards this. So to that end, we're rather fortunate about the timing.
Yeah.
I was curious because, a lot of people talk about ammonia as like storage for hydrogen. Could you talk about kind of the benefits of it being just used as a storage versus it being used as a fuel in comparison to hydrogen?
Sure. So, I think both of those benefit from some of the same characteristics. So, for example, if you think about whether it's storage or whether this is fuel that's being transported and used at the end use location, it certainly helps that ammonia has high energy density. It's actually about 30-40% higher than liquid hydrogen, which is great. It also helps that it's stored at very reasonable conditions. So, with hydrogen, you have to go into rather high pressures. Depends on applications, but for mobility, it's typically anywhere from 250 to 700 bar, or very deep cryogenic temperatures, negative 250 Celsius, close to absolute zero. With ammonia, you store it in a very similar way to how we store propane. So either at moderate pressure, about 10 bar, or at low temperature, but not that low, roughly negative 35 degrees Fahrenheit, which is about the same in Celsius. So, it has been both forms of storage have been implemented at a commercial scale. So when you think about this high energy density and low cost storage, it benefits both storage and using it as fuel. The way we think about this problem is, well, once you have it already in this very highly energy dense, easy to move around and store form, why not use it as fuel?
Yeah.
So that's how we're thinking about this. And, of course, it's various applications will choose different fuels. We don't think there's necessarily a need to use ammonia for applications where other solutions work perfectly fine. Good example of this would be passenger vehicles. I think this problem, either to some extent already has been solved with EVs. Of course, this will be evolving landscape. But there are applications like maritime shipping where we don't currently have other viable solutions. And if you think, for example, specifically about maritime shipping, which is one application we really like and that we're moving very quickly in, if you look at what the forecasts are by various third parties, industry experts, consultants, of course, in the future, we'll see energy mix and that space split between different types of solutions, different types of fuels. But most of these forecasts see the role of ammonia as anywhere between 1/3 and 2/3 of the total energy mix in 2050. So, I think there's a quite substantial role for ammonia as fuel. This is the way that we're pursuing, but there are arguments that also make the use of ammonia as a storage solution a viable one.
Interesting.
And what about, since you spoke about shipping and I have a little bit of background within shipping, how much volume is required on board a ship, versus traditional fuel that's used on ships?
It's a great question. I think we, with any low carbon molecules, it just kind of goes into the physics of it. The bond between carbon and hydrogen is a fantastic bond from the energy density perspective. So if you look at any type of fuel, whether it's ammonia, methanol, hydrogen, fuels that have been partially oxygenated, they all have lower energy density compared to diesel or marine gas oil. So looking specifically at the numbers, we we would need about 2.5 times more fuel with ammonia compared to diesel, assuming the same efficiency. There are ways to increase the efficiency, and that's what we're doing, for example, by using fuel cells. So we actually crack the ammonia first and then use conventional off-the-shelf fuel cells to produce electricity. But broadly speaking, I think that's something that you'll see with all of the alternative fuels, maybe other than SAF, but I think bulk of SAF production will be used for applications such as aviation.
And I think one of the things that I'm curious about is it seems like there are a lot of different applications, and you're going all in on shipping, which seems counterintuitive to me, because I would assume there's a big aversion to risk, and then it's just because the capital projects are so big. But you're a strategist, so you know why you're going into this market versus others. So I'd love to hear your thoughts about why is this the entry strategy?
Well, I mean, you made a very good point. Amogy did not start with a mindset of we're going to develop the systems for maritime industry. We sort of arrived at that point over the 3 years of our existence. We started by powering a drone with ammonia, and the idea was, well, let's prove it that we can have much longer flight duration compared to drones powered by batteries, and we kind of took it from there. There are several reasons why we believe that maritime is the right segment. First of all, maritime needs a solution, and maritime industry needs that solution now. So I think you'll see this across many different segments. Companies tend to make commitments with 2050 timeframe. Usually these are net zero commitments. If you look at, for example, passenger vehicles, their lifespan is relatively short. So they may be on the road, I don't know what the number is, but probably somewhere between 5 and 15 years. With maritime vessels, the vessels that are being built right now, many of them will still be in service in 2050. Typical lifespan is, and you would know it better.
Yeah, I would say like 50, 60 years. Yeah.
So that's why these solutions need to be implemented right now. And we see maritime industry, which historically has been relatively conservative, moving in this direction fairly quickly. It certainly also helps that we have a supportive regulatory environment at both demand and supply side. At supply is maybe something that applies to many other hydrogen derivatives, for example, with US, with the IRA, Inflation Reduction Act, and the 45Q incentives for CO2 storage. But on the receiving end, with maritime, we have recently revised guidelines from the International Maritime Organization, putting it at net zero by 2050, but also quite significant reductions leading to this. So 2040 is actually 70% reduction in emissions. And even 2030, you see that it's between 20 to 30% for greenhouse gas emissions and a target of 40 for CO2. So, this in maritime, it's a transition that needs to happen now and needs to happen at scale with a scalable fuel. It's an industry that I think there's a broader alignment that ammonia will be a significant part of the energy mix.
Interesting. It's a good illustration of when there's a pain point. There are solutions that need to be designed, built, and deployed. And I'm glad you guys are leading the charge.
No, and I know there's immense pressure from the IMO. And all shipping companies are working on their decarbonization plans. And currently there's no fuel alternative available. So a lot of them are investing into ammonia and looking into it. So there's definitely a big market. Now, you said your technology mostly focuses on converting that fuel, ammonia, into power. So could you tell us a little bit about how that technology works?
Sure. So maybe to take a step back and look at ammonia and potential use of ammonia as fuel. Part of the reason why ammonia hasn't been used as fuel until now is ammonia is very difficult to burn. The range of flammability. So you need to get the mixture of ammonia and oxygen or air just right. And even then, during combustion process, for example, in an engine, the velocity at which the flame moves is very, very low. So that makes combustion of ammonia rather challenging. Not impossible, but challenging. Also in the process, there would typically be some NOx emissions, which requires you to include additional emission reductions or capture of this NOx. So we looked at this process and we thought, well, there's probably a better way of doing this. So our system works on a different principle. What we do is that we take ammonia and then we crack it. So cracking is a process of thermocatalytic decomposition at elevated temperature with a catalyst, but for our technology, and one of the reasons why we can actually have our system being a fairly small package is that the temperature is much lower compared to conventional cracking solutions. So once we crack the ammonia, instead of ammonia, we get a mixture of hydrogen and nitrogen. Nitrogen is inert. Most of the air is nitrogen. And then we have hydrogen. And you can use hydrogen really in any way that you desire. The solution that we see as an advantage one right now is the use of this hydrogen with fuel cells. And these are, conventional PEM fuel cells that have been demonstrated at the commercial scale, that are commercially available and have been used in other applications. So what we offer to our customers is a complete solution going all the way from molecule, and that can really be any form of ammonia, whether this is compressed or slightly cryogenic ammonia, all the way to electricity. So we see the need of, rather than offering subcomponents of the system, to offer a complete solution in a modularized fashion that, customer can take and can say, well, I want 1 box or 3 boxes or 10 boxes. And that way we can match electricity production to their demand.
So hydrogen is a byproduct?
Well, it's a product of the reforming process, right? It just pops out of the molecules, right?
Correct.
Essentially.
Correct. So ammonia is NH3. So it's for every 1 atom of nitrogen, there are 3 atoms of hydrogen.
And
so you release quite a bit of it as you crack ammonia into nitrogen and hydrogen.
And I guess the lucky thing here is usually with methane, which is the CH4, the carbon likes to attach to oxygen, and that's where you get your carbon dioxide, which is bad, right?
Yeah.
With ammonia, the nitrogen likes to bond with nitrogen, which we know is just not really. I assume it has no global warming potential because it's the air,
right.
And that's like one of the fundamental differences. And then it's inert, so you just have your hydrogen floating around in air, essentially, right?
And that's the beauty of it. And that's the beauty of ammonia, is that there are no tailpipe emissions. So if we can produce zero carbon ammonia, and we can, or very low carbon ammonia, we not only can, but it's being done at a considerable scale, then you don't have any meaningful emissions downstream of it, other than, of course, if you're moving the fuel around, then there may be some emissions associated with it. So it's ammonia is a very, very interesting molecule.
And I appreciate putting it into a fuel cell, because this is like a nice engineering exercise in some ways, where it's the right solution for the right set of components. And fuel cells notoriously want very purified fuel streams, and so you're giving it to them just as a natural part of your process. And that kind of begged the question of what's Wärtsilä doing, because they're kind of one of the big engine manufacturers. And I think you already addressed that. Kind of putting in like an ammonia as a fuel source is challenging, because then you're gonna have to put in like a NOx control system, and I don't think anyone wants to carry around extra def to do that like they would have to, if you were doing like on land ammonia control. And so that ends up adding complexity in other places where the fuel cell just makes it nice and controlled and effective. And I think that's a very nice insight, and you can see why it's the right time and the technology is there, where really there's not a lot of risk outside of the reformation process that you guys have.
Where I think it's one of those cases where the stars kind of align between the market, the product, the timing. Of course, there's still a lot of work that needs to be done, and you mentioned Wärtsilä, which is one of the engine manufacturers. Of course, the engines are in development too, and we're really cheering for all the participants of the value chain, because we fundamentally we want to address the problem. And if others can help, can build even more momentum for the industry to move forward, and for adoption of low carbon fuels to increase, we're very supportive and very much willing to work with others across the value chain.
Yeah. Well, if you ever get an invite to the Wärtsilä plant, you have to take me, because I love engines. I love big engines, so I would love to see one of those.
Absolutely.
So talk to us a little bit about the scale of ammonia that would be needed to transport, right? And also in comparison to the ammonia we produce today for fertilizer use, and the amount of ammonia we will have to produce to actually run the maritime industry.
Sure. So global production of ammonia today is around 200 million metric tons. MTA, which I mentioned before is roughly 40% that of LNG. So it's very sizable. About 90% of that ammonia is converted into various other chemicals or used, let's call it, without having to move it by ships. But about 10% of this ammonia is moved in the form of anhydrous ammonia around the world and moved by vessels. It's actually very interesting. It's some cases these are the same vessels as LPG vessels. So vessels carrying C3 and C4, C2 and C3 molecules. So the infrastructure, there's some flexibility in terms of utilization of infrastructure between hydrocarbons and ammonia. If you think about the total demand that for ammonia that may exist, the predictions is that that global demand and correspondingly production will be probably somewhere around 600 MTA by 2050. So increase by a factor of 3. And the interesting part there is, whereas currently bulk of ammonia is the end use of it is production of fertilizer, the prediction for the future is that most of it will not be used as fertilizer, but rather used as hydrogen carrier or as fuel. And the interesting thing is that this is not a vision of the future only. This is something that's already materializing. So we know that developed Asian economies, for example, Japan and Korea, already have in their energy policy the plans for utilization of ammonia. Right now, the first step is primarily, let's bring ammonia and then co-burn it with coal, because that's the easiest to implement from technology standpoint. But of course, there are more efficient ways of doing this. One way is to do it the way we do, but there are other ways to produce electricity from ammonia that can materialize in the future too. So the momentum is really there. I think what's really encouraging is that sometimes when you look in decarbonization space, it's a little bit of chicken or egg question. Everyone knows that things need to happen, but there's always a question, well, what comes first? Is it supply? Is it the demand? Is it the infrastructure? Who's going to take the risk? What's beautiful about ammonia is that, the infrastructure largely exists. You have support on the production side. On the demand side, we have ways in which we can already ramp up this global trade of of ammonia.
Mm-hmm.
So it's one of these cases where we can grow the solution and proliferation of ammonia as fuel and as a hydrogen carrier fairly organically. It does not need to be a step change, and it's a process that will really take advantage of the solutions that either already exist or are very close from being commercially available, such as our system.
No, and you've seen that already in the market, the interest not only from investors, but also from partners. So could you talk a little bit about that? You've only been around for 3 years and you already closed your Series B round.
Yeah, thank you. So the company has been around for 3 years, and we have been very fortunate to have a lot of support of our investors during this period. So earlier this year, we closed our Series B round. That was $150 million. We have so far attracted $220 million in capital. We have gone through our seed round, Series A, and most recently Series B. Over this time, we saw a shift from, first the pioneering approach of trying to get on a conceptual level, the technology right, through, working out some of the technology kinks and really getting our product increasingly mature stages. We have now entered some time ago a commercialization phase where our focus is still on demonstrating technology in maritime application. That's why we're building the world's first ammonia-powered tugboat 1 megawatt system, so at a reasonable scale. But we are also beginning to think about, what comes next. So not only building the commercial product, but also structuring partnerships. We're fortunate enough to having secured our first pre-orders for the commercial product, and also thinking about how these products will be manufactured. So to that end, we are building the facility in Houston that will be opened in early 2024. It's roughly 50,000 square feet facility that will enable us to manufacture the systems at a fairly considerable scale. So I think we really benefited from the momentum in the market, and I'm fairly confident that we have the right product to address this need. So hopefully some of these announcements will continue as we go.
So this facility in Houston will be actually making these modular systems.
Correct.
What do you call them?
We call them power packs.
Power packs.
So these are what it is. It's a box. It's a complete ammonia to power solution, and the scale of it is about 200 kilowatts. So one module has a power output of around 200 kilowatts, and then if you want more of these units, you can build them in a modular fashion, kind of like Lego bricks.
So one of the things I'm curious about, and we'll kind of delve in a little bit into Houston, is I think Houston likes to tout that it's friendly to business, and I'm curious what the search was like to identify a manufacturing facility. I'm going to assume you're only looking at Houston because I'm proud of Houston, but like, did the city open its arms? How did you find the right facility?
Yeah, so I think there are a few of us on the team that have prior experience from Houston. There's big reason for why we moved here was just the wealth of knowledge available in the Houston area. You have all of the oil and gas companies, engineering, procurement, and construction companies, service companies, utilities. It's really kind of a critical mass. And I think we saw reflection of this critical mass and some innovative thinking in the form of all the startups that mushroomed in Houston over the last few years. But it also is a very important factor for why we chose Houston as a location. Of course, we're building hardware. We need great chemical engineers, mechanical, process, technologists, EHS staff, technicians. The availability of knowledge, people that have been rigorously trained in well-established industries, was a very big factor of the decision. And of course, it certainly helped that we're able to find the right facility. I think perhaps what's very telling about the transition that is happening in Houston as well as globally is that our facility used to serve as an oilfield services facility for one of the major providers. So now it's going to be repurposed and quite significantly re-engineered for our purpose. But it's we're really excited to see the transition that's happening in Houston, and of course you see the transition in terms of names of companies and announcements, etc. What we're really excited about is people. Seeing the appetite and the drive within our team members, many of whom come from conventional energy companies, appetite to build something and appetite to pursue something in decarbonization or low carbon solution space. It's really, really encouraging, and Houston has a lot of that energy.
Wait, I don't know if we said it before. Where is the facility at in Houston?
So it's northwestern Houston. It's in the Jersey Village area.
Okay, yeah, big corridor for oilfield services. One of my first offices was up there. It was the one I was in was an old Schlumberger building, but they're just sprinkled out there. Good.
Yeah. No, we're glad that you're here, and we would agree that Houston does have the best talent for what you're doing. But, the company started off in New York because that's where you're headquartered. And I've heard that, New York has an amazing startup ecosystem, second only to Silicon Valley. But, tell us a little bit about your journey personally, where you started off, how you ended up joining Amogy, and then how Amogy has taken advantage of being in New York.
Sure. So my personal journey actually took me through both New York and Houston, which was exciting, and I personally love both. I started as an engineer. I was trained as an engineer first in Poland. Then I became very interested in geothermal energy, and Iceland was the right place to do this type of work. So I went to grad school in Iceland and Sweden, came to US to do my PhD in chemical engineering, pretty much all of it around renewables, geothermal, solar, battery storage, later on grid operation and demand response. Funnily enough, I worked on ERCOT at the time. And from there, I started or moved to the industry to a large oil and gas company, starting in engineering roles, LNG, hydrogen, ammonia, flare gas mitigation. But I always had some craving for the commercial side of things. So, got first exposure to it through business development, and then ended up on the mergers and acquisitions side, which I highly recommend to anyone. It's a really nice way to balance the view between technical and commercial. And from there, I joined Amogy. I've been with the company for about a year and a half, so roughly half of the time that Amogy has been around for. And during this time, the company has grown from about 50 people to over 180. So we have experienced quite a significant growth. It was really fascinating to see it from the inside. As you mentioned, we started in New York at a startup incubator called New Lab. Our headquarters is still there in New Lab, and we take a good portion of the space. we have received a lot of support from them early on. It's really the company started with 1 desk, then it was 4 desks, and then we grown from there. But I think it's here in Houston we have Greentown Labs, and I think environments like this are really, really important for enabling this environment to thrive. It's of course what we're trying to do right now is not easy. It never is until you're a mature company with a significant revenue and a strong balance sheet. But I would argue that it's much more difficult to start it than it is to go through this more mature phases. So having places like in Houston, Greentown Labs or New Lab in New York is really, really important.
I'm so curious on the kind of mechanics of scaling up that many people. Because on the one hand, I'm like, that means you're adding like 3 people or 2 or 3 people a week, it seems. And I'm very curious how you keep everyone kind of pointed in the same direction. And I'm just imagining when we used to onboard people, we'd have to make like a whole like 6-week plan, and we'd have to like give them all these materials. And I'm thinking, man, if every manager had to do that and it was hiring once a quarter. I mean, it's important because you need people to do the work, but I could see that if you don't get it right, it could be very challenging. So how have you guys done it right?
I think what worked really well for us is that we hire for personality. We hire not only innovators, but we hire really good collaborators. And I think if you have a team that works really well together, where people's hearts is in the right place and they can prioritize, things kind of tend to fall into the right places. Of course, it's never easy to grow at this rate across multiple dimensions, because it's the technical and R&D and manufacturing, safety, commercial, etc. But we have been, I think, reasonably successful in this. Being in Houston, of course, gives you also access to the talent pool. We've been very fortunate to be also able to attract some of this engineering talent into our offices in New York. So all of this growth is not without a challenge. It requires commitment. I believe that we still have about 20 open positions at our website. So, to any of our listeners, if this line of work is interesting to you, please connect and look at the opportunities. It's not trivial, but I think if your heart and mind are at the right place, then it's very, very manageable.
Yeah, and I want to ask, I guess, a little bit. When you find people are coming from traditional energy, I think there's always a concern that maybe they have to reskill. Do you find that like where a lot of your candidates are coming from, are they coming from traditional energy, and do they need to upskill?
There's of course a new skill set that's required. I don't think this is a significant barrier. What we're seeing with our team members who came from more traditional energy, who joined from traditional energy backgrounds, is that they really have a rigorous way of thinking about things, mature approach to engineering, to process and product management, and the right mindset about safety too. So I think there's a large pool of people who have that technical skill set. You look at, for example, oil and gas companies, it's in terms of training and the knowledge, they're really some of the best training grounds out there. And at the same time, some of these people have appetite maybe for a little bit more commercial risk, because startup will always include more of that, but also seeing the impacts of your work immediately, being able to build something with your own hands. And I think also gaining expertise that is increasingly valued in the market. I think there's a general consensus that we'll need to decarbonize. And these opportunities are there in terms of jobs, but they will only increase and increase. So I think it's a very much a mutually beneficial opportunities for people to do perhaps what some of them really want to do, but also for us to get team members who have this very solid background and understanding.
So you've been around for 3 years, and if my calculations are correct, then you started off during COVID. And the 3 years following COVID hasn't been great for venture capital, I would say. And you're one of the companies that I've seen, it's an industrial company, you're trying to build an industrial solution, and has been quickly able to get the funding that you need, go from like concept phase to demonstration and be where you are today. What do you think worked in your advantage? What did you guys do differently?
It's...
other than hiring the right people.
Yeah, it may sound like cliche, but I think it's really do you have the right solution addressing the right market? What we're seeing with ammonia is that the potential is tremendous, and the solution wasn't there. So that certainly helped. We have done our fundraising throughout times that were very, very attractive, and our Series B most recent, arguably earlier this year at a time when the market has gone down. I think the story behind success is right mindset. Really, really collaborative team. I'm still amazed by our team and just seeing, how, not what we work on, but how people work, how they collaborate together. And that, of course, you see this every day when you work within the company, but it creates a little bit of a halo effect that I think is discernible to the investors too. So that certainly helped. You mentioned COVID. COVID has been such a period of ups and downs, and we saw this, of course, with electricity, especially here in Texas, with oil, but also, all of the natural gas derivatives, including ammonia. Ammonia is being decarbonized now, perhaps faster than any other molecule, but it's still to a large extent same like hydrogen produced from natural gas. So the volatility in the market has been pretty significant. So I think it's one sense perhaps not the easiest period. In other ways, it's great training ground. You've seen the highs, you've seen the lows. Hopefully, most of the time in the future we'll not be pushing these limits again, but we'll be somewhere in between.
I'm actually a little curious in some ways about the next round, and because you're at this fun phase where you're starting to, you said you have commitments for pre-orders. You're starting to make stuff. That means real revenue. It means a different stage of life for the company and a different view from investors. And I guess I don't know if in your perspective you're able to see, like, are you starting to cater to more of a private equity investor? And so let's start there.
Yeah, so we certainly have seen this throughout Amogy's journey, with the early capital coming from VCs, later on, with significant portion of strategics, and then in the last round, some early indicators of other profile of investors, asset management companies with, let's say, more of a financial perspective than strategics that look to a larger extent at the fit of that startup into their own operation. So for us, it hasn't been a step function. It has been more of a gradual transition. But you're absolutely right. I think the company is, again, moving from technology development to technology deployment, certainly more focus on commercial side of things, key focus on commercialization and product rather than just technology. And most certainly Series C will have a bit of a different flavor compared to Series B, but we also anticipate that always to be the case.
Yeah. Interesting. And I'm curious, everyone always has questions about IRA and how it gets implemented, and you're going to be living it. And at some point that really impacts the financial model. I mean, how does that change, I guess, frame your thinking about the actual deployment of the technology?
So the primary way in which IRA affects us is indirectly through our customers. So, our customers, most of them are currently using diesel or marine gas oil. They want to transition to a low carbon fuel, but of course, the economics are largely driven by the cost of fuel itself. So having lower cost fuel is of tremendous advantage. Right now, we see a lot of momentum in the US for low carbon ammonia production. And that comes, smaller projects are green projects. That's typically of the order of 20,000-30,000 tons per annum. So 20-30 KTA. There's planned next phase, which will be more of a scale of 1 million metric tons a year. So these are like truly global scale facilities. But in the meantime, what's really interesting, what's happening is we see the existing ammonia plants decarbonizing. So we see carbon capture and sequestration plants being implemented to make blue ammonia. And the impact of IRA on ammonia is actually really interesting. I sometimes say that it gives more benefit to ammonia molecule than it does to hydrogen molecule, and that's because if you think about it from the point of view of production, that's one thing. But if you think about it from the point of view of end user, what they see is the delivered cost of fuel. So if we think about ammonia, well, most of the cost is on the production side. So any incentive that we can get to production of ammonia translates quite directly into the cost of the delivered fuel. So I think that's why IRA will have such a tremendous impact. And on IRA, we have the incentive for hydrogen production, which is, I think most people agree that for blue hydrogen, it varies depending on how much carbon you store, but it should be around $1 per kilogram. For green molecule is around 3. Now, if you think about ammonia production costs, where really 90% of the cost is embedded with hydrogen and very little of it is required to pull nitrogen from the air and combine it with hydrogen, really any incentive that you get on the hydrogen production side translates onto ammonia production cost. And that in turn, because of low cost of transportation and storage, translates well into the cost of the delivered fuel. So that's why IRA and 45Q are such a important legislations for ammonia production, and from our perspective also ammonia use.
Got it. I can see why you're excited about it.
It shows, right?
Yeah, that's good. Let's see. I guess we're kind of running low on time. I guess we talked a little bit about coming to Houston. You've been personally traveling to Houston, I guess once every month or so. What's been drawing you here, where you're kind of proud of how the innovation ecosystem has evolved?
That's a leading question.
It is a leading question. It is very much a leading question.
Yeah. So, of course, with such a big part of company's operations here, there's a very good reason for me to be here. And, from Amogy's perspective, it's the talent. It's the momentum in Houston, I would say, especially on the people side. I do have a soft spot for Houston. I spent 5 years here, and I still miss Houston food scene and having.
Can you find good Polish food?
Hold on a second. Time out. You're in New York.
Yeah.
Isn't it? I can't imagine you're competing New York and Houston.
They're
just
food?
different. They're just different.
Both are fantastic.
Okay.
Yeah.
I think Houston is highly underrated.
Okay.
Houston. I think food scene in Houston is fantastic, and it's such a versatile city.
Do you find good Polish food here?
I never actually tried. I'm sure it's there. I can actually think of one restaurant that's in the Katy area.
I love the pierogi.
Oh yeah,
from Poland. Yeah.
I don't think it's perhaps as well represented here as it is in New York. And I'm really hoping that some of our listeners will correct me and will mention
Let us know.
a few good places, and then I can go and visit them.
Sorry,
No, that's
got
okay.
distracted.
You got too excited.
And I guess one of the things I want to go back to on the talent, because you've been here before, do you think there's a shift in sentiment towards to how people think about climate and the energy transition?
I think so. I tend to see things now through the lens of a startup, and my exposure is primarily to a startup environment. So as I have made my personal journey, I think I'm seeing more exposure to it too. Places like Greentown Labs are, really moving the needle for the local environment. But I think it's not only the innovation environment. I remember when I was still in the oil and gas industry, and we have made this transition that occurred in most oil and gas companies from teams devoted to lower carbon solutions and technologies being very small, sometimes even single digit, to now some of these teams in major companies being of the order of hundreds of people. And, if you think about the pace at which this transition occurred, it's really spectacular, especially if you overlay this with, the timing, the COVID, the, let's say, more focus on capital efficiency and strengthening the balance sheets within this period. It's, if there's one observation that really speaks to the pace of energy transition, I think to me, this is the one.
I'm curious. So you're talking about your own journey. Have you ever had your own climate impact story?
Throughout my time in this space, several times when you see a solution and you just know that this is going to work. I remember when I was in grad school and I worked on low carbon refrigerants. Realization that the refrigerants that we use in air conditioning systems in automotive vehicles contribute about 1% to global warming. It's actually not that difficult to replace them.
Right.
Then, working on the demand response in electric grid, which was interesting. It was actually here in ERCOT. I remember finding out that there, especially in Texas, we have these peaks in energy demand. At the time, there was this program that really incentivized the customers to reduce their electricity demand during only 4 short periods during the year. I think it was of the order of 4 times 15 minutes. And what we found out at the time is that, well, if you can basically reduce your energy demand, in this case we looked at data centers, during this period of time, you not only can really help an electric grid not use some of the most carbon intensive resources and maybe power plants that are fired a few times a year, you could at the time reduce the cost for the end user by somewhere between 5 and 10%. So which was, for industrial scale facilities, really, really interesting. So, I think there were a few cases like this, but one feature that all of these cases had in common was a this was a scalable solution.
Mm-hmm.
And I think that also links really nicely to startups, because what we tend to do is identify the solution where maybe, you move the needle by a lot or by a little, but the size of the problem is so significant that even if you move it by a little, the end result is still very, very high.
Yeah. That's fantastic.
Yeah. Yeah. So as we are coming to the end, I mean, this was such a great, informative podcast. What is one thing our audience could support you in your goals?
Great question. I think our goal is to decarbonize the industry and the heavy-duty transportation, maritime power generation. It is very clear that this is not, it's not a problem that can be solved by our company alone. To that, we need help from customers, financing institutions, from shipyards, from maritime naval architects, integrators, really across the full value chain. So, it is a solution that will have to be implemented across the full value chain, and I think that's how you really drive the distance. Now, I know that not all of our listeners work in this space, so I think it's really important that all of us do what they can do. As I mentioned again, if there are listeners that are interested in this line of work, please connect with me on LinkedIn or through a different channel, and we would be more than happy to have this conversation.
Yeah. Is LinkedIn the best way for people to follow Amogy?
LinkedIn is great. We do post quite a bit on LinkedIn. We also, our website is fairly informative. We recently published some white papers there as well that I think provide a fairly good overview of the industry, and it's not only our view, it's more of an independent third-party view. So, but LinkedIn is great. That's the primary channel that we use for interacting with others in the space.
Yeah. Well, thank you for being here. We're excited to see what the next year holds.
Good luck.
Thank you so much.
Look forward to having you back.
This was really a pleasure.